So this is chapter 10 of the Edexcel Year 2 Pure book. We're looking at numerical methods. Now, there are three sections really in this chapter. There's a little section on locating roots. There is the iteration section, and then there's the Newton-Raphson method. Now, you may well have seen iteration as part of GCSE or one of the GCSE courses. What I think will be unfamiliar to you will be these diagrams and the explanation as to why the iteration method works. And Newton-Raphson will probably be new to everybody on this chapter. But locating roots is what I'm going to try and deal with in this video. And in a lot of ways, this is really straightforward. There's not a huge amount we've got to say here, but they've made it into a full exercise. And I think the reason they've done that is because though the idea here is fairly simple, when we turn it into algebra, it seems like it becomes quite complicated. And secondly, because when you're doing the iteration questions, you usually get a few marks in the exam for checking that you have the correct answer. And the way that we do that is by using the locating roots method in section 10.1. And I don't know how this is going to be on the new exam. I'm filming this in 2019. This exam's still fairly new. On the old module, when students were asked iteration questions, they'd get the first few marks really easily. They're nice places to get marks. And then they'd lose the last couple of marks by not doing the sign check using the locating roots. Okay, so what do we need to know about locating roots? This is what we need to know. First of all, two bits of information. We have this notation, AB, and sometimes we'd say AB like this with the square brackets. And what that means is the interval on the number line between A on the number line and B on the number line, and we're looking at the numbers in between. Okay, so we might be used to this notation. X is between A and B, and it's just the same way of saying that without having to introduce an extra letter, X, that we're going to put in the middle. Sometimes you'll find that this AB notation is an exclusive inequality, and this AB notation with the square brackets is an inclusive inequality. And then you can have things that look like this. A is less than X is less than or equal to B, exclusive at this end, inclusive at this end. But it doesn't really matter, as you'll see in the textbook. They've used the square brackets to mean the interval between A and B with exclusive inequalities, and that's fine because in this chapter we're not really going to be interested in what happens at the boundary. We're interested in what happens in between the A and B, really. So that's the first thing. Second thing we should be clear about is this. If we have a function, we have y equals f of x. So that f of x, remember, can be any algebraic expression. It could be sine x, cos x, e to the x, natural log of x, a polynomial in x, a quadratic, any algebraic expression there, okay? If I write this, 0 equals f of x, these two things are different. This is a function, y equals f of x. This represents pairs of values, x values and y values, and we can draw that as a function on a graph as a sort of wiggly line. This thing is an equation. This is going to have solutions, x equals this or x equals something else. Maybe there's one solution, maybe there's two, maybe there's lots of solutions, but this is an equation. This is a function, this is an equation. Okay? The solutions to this equation are the roots of this function. Just be clear about these words. This function has roots. The roots of this function are the solutions to this equation. But this thing here and this thing here are not the same. This is a function, this is an equation. Okay. Now, once we've got all that clear, it should be, if we think about this the right way, it's not too tricky here. Y equals f of x is a curve. So here we go, here's a curve. And 0 equals f of x is an equation. The solutions to this equation are the roots of this function. Well, what I've done here is I've taken the function, I put y equal to 0. So the roots of a function are where the function crosses the x-axis because it's the points where y equals 0. So if this function is going to cross the x-axis, that's called a root. There are two options. I've drawn one of them here and the other one I'm drawing here. If we're going to cross the x-axis, either the function goes from under the x-axis to above it, or it goes from above the x-axis to below it. If the function is below the x-axis, it's negative. If it's above the x-axis, it's positive. Here it's positive, and here it's negative. So if there is a root of the function, then there is a sign change in the function. The function goes from positive to negative, or it goes from negative to positive. And that really, that idea in your head is if you've got an x-axis, if the function's up here and it's going to get to down here, if the function's going to cross the x-axis, if the function's going to get from up here to down here, it's got to cross the x-axis at some point, and that point there is what we call the root. With diagrams, thinking about it geometrically, it's that simple, and that's the idea you should keep in your head. The algebra is going to make it feel more complicated, but just keep referring it back to this idea, and hopefully it'll be straightforward. One other thing to point out, we've assumed that we don't have a function that looks like this. We've assumed that we have a continuous function. So for our purposes, a continuous function is a function that you can draw without taking your pen off the paper, okay? So this function here, it looks like an inverse function, or a 1 over x kind of a function. This thing here has a discontinuity at this asymptote. At whatever this value is here, there is no y value for the x value input. So it goes from here, you draw this bit, you have to take your pen off the paper to come back and draw this bit. It's not a continuous function, and obviously that means that we can get from above the y-axis to the x-axis without going through the above the x-axis to below the x-axis without having to go through the x-axis, because we can just take our pen off the paper, okay? So we need a continuous function. The second thing is, if we look at this example, we've gone from above the y-axis to below the y-axis, but there's actually 3 roots in between. If there's a sign change, it doesn't mean there's just one root in between, it means that there is at least one root in between, because this can happen. And then, if there's not a sign change, it doesn't mean that there is not a root. Okay, and fairly obviously, look, here it's negative, here it's negative, but it could have gone positive and then back to negative in the interval, okay? So if you've got a sign change, if you've got 2 numbers a and b, and if f of a and f of b, this is where we're starting to put it into this algebraic notation, so f of b has a different sign to f of a, so this one's positive and this one's negative, or this one's negative and this one's positive, whichever way around you want to do it. If there is a different sign, then there is a root of the function between a and b. There's a root of the function in this interval. It doesn't mean that there's only one root. There could be several roots, but there is at least one, okay? And I think that's really is it. That is all the information that we need to know. Example 2 there is stressing the point that we just made. If f of 1.1 and f of 1.6 are both negative, the student says there are no roots in that interval, and that's not necessarily true. It could go up and down again. Calculate f of 1.3 and f of 1.5 and explain why there are at least 3 roots in this interval. So f of 1.3 is, here we go. There we go, it's positive. F of 1.5 is negative. F of 1.7 is positive. So from 1.1, it's negative to positive, so there's a root in there. Then it's positive to negative, so there's a root between 1.3 and 1.5. Then it's negative to positive, so there's a root between 1.5 and 1.7. Okay? There's no absolutely set way of setting these out, just using this function notation and saying, well, this one's negative, that's less than 0, this one's positive, that's more than 0, and then writing a sentence to explain it is fine. And you can get the idea of a few sensible ways of setting it out from the blue boxes here. So quite a bit of detail there for what you might be thinking is a very simple idea. Have a go at section 10.1, exercise 10a, see how you get on. We'll carry on section 10.2 on the next video.